Hello guys, good morning. Welcome to Brain Insights Academy, your pathway to academic excellence and success. Now today we are going to continue our lesson with mensuration. Mensuration 1. Mensuration 1 is made up of plain figures, or mensuration 1 deals with only plain figures. So the last time we talked about circles and I gave assignments before I went, but I haven't yet gotten any solution from none of you. So I'm still waiting for the solution for us to know whether you get the understanding or not. And yes, I think yesterday, Wise Man in the group, yeah. I mean that's his name. He's called Wise Man, yeah. So Wise Man in the group, WhatsApp group, um sent me message in a WhatsApp group that he doesn't know how to comment in the description or in the comment section on the YouTube platform. And this one I think is the problem of the day because most of you don't know how to comment under it. So I'm going to get you a video of it right now. After that, then we dive into this session. Let's go. Welcome to Brain Insights Academy, your pathway to academic excellence and success. Today we'll be diving into mensuration one. Mensuration one. If you are watching the videos but you are not subscribing, liking it, commenting, and then sharing it to friends, this is what also benefits us. We are not charging you for tutorials. We are not taking any credit from you for tutorials. Just share the link on your WhatsApp platform, on your Facebook, on other social media channels, so that you will get more subscribers, and then more people will benefit from it. People, we want the whole Ghana student to benefit from this program. That's why we are bringing you about. So okay, so welcome back. Today we are going to talk about mensuration. Mensuration 2. Mensuration 2, the last time we talked about circles, so we are going to talk about other plane figures. Other plane figures. There are so many plane figures, but they all start with number of sides 3 upwards. So we have 3, number of side 3, number of side 4, and so on. So with mensuration, you will be dealing with only the triangles and then the quadrilaterals. Triangles and then the what? Quadrilaterals. Yeah. The quadrilateral, when you say a quadrilateral is a four-sided figure. A quadrilateral is a what? Four-sided figure. Good one there. Quadrilateral is a four-sided figure. So let's talk about triangle first. Oh, I think we should talk about the quadrilateral first. Yeah, I will show you something here. So with Brain Insights Academy, I'm not just going to teach you how to um solve the question as well. I'm going to teach you how to remember, or how you will not forget the formula of triangle, and also you will not forget the formula of other plane figures. So with quadrilaterals, give me some examples of quadrilaterals. I mean four-sided figures shaped. Okay, I'm listening. I'm listening. Yeah. So we have with the quadrilaterals we have um with the quadrilaterals we have square, we have what again? Rectangle, we have what again? We have parallelogram, wonderful. We have what again? Rhombus, yeah, good, good. And we have what again? Kites, sure, sure. So these are all quadrilaterals because they are what? Four-sided figure. Okay, so let's talk about a rectangle first, a rectangular object or rectangle first. So a rectangle, oh, so rectangle is drawn like this. I think most of you know the formula for rectangle, how to find the area of a rectangle. So what is the area of rectangle? Area of the rectangle equals what? Equals length times breadth or width. Let me use width rather. Yeah, rectangle is, you can choose any of them. Yeah, this is the formula for rectangle. The length times width or length times what? Breadth. Yeah, that is rectangle. The longest side is called the length and the shortest side is called the width. So when you come here, rectangle is the first or is the first quadrilateral that I'm talking about here. But I'm coming to teach you how you can come up with the other formulas based on this rectangle. Based on this rectangle. Yeah, so this actually for rectangle. And then when it asks you the perimeter of a rectangle, what's the perimeter? Is the distance around it. Beautiful. It's a distance around it. The perimeter is the what? Distance around it. Let me clap for you. Let me clap for you. Yeah, so perimeter, I told you perimeter is the distance around for it. So when you come here, you having this distance plus here, plus here, plus here. Here is length. Let's use L to present it. W to present here, L to present here, another W to present here. So when you come here, perimeter is the distance around it, the sum of the distance around it. So we're having our perimeter as L plus W plus L plus W. But you can see that in algebra, let me know if you don't understand algebra so that I will also take my time and then do a one video of it explaining algebra to you. So algebra, you know L is 2L. So we have 2L plus 2W. 2L plus 2W. LL plus 2W. So this is our perimeter of a rectangle. Rectangle. Now let's move on to triangle now. Let's move on to triangle now. Triangle comes from quadrilateral. Triangle comes from quadrilateral. Yeah, so especially this shape, this how triangle came from it. So have you written this one? Yeah, let's move on to this side. This how it is. Okay, let me draw the full shape. It's actually rectangle, right? So when you divide rectangular object into two, you are going to get a triangle here, a triangle here. Because it's what? Three-sided figure. Beautiful. Because it's three-sided figure. So with here, that's how it looks like. We know the formula for, or we know the area of a rectangle to be what? Area of a rectangle to be length times breadth. Let me use variables to present it, which is LB. So we know the area. Area equals LB. This is how you can come up with the triangle formula. So when you check here, I'm going to raise this side for us to get the triangle. When you check here, this triangle, for instance, is half of the what? Of the rectangle that I drew. Is half of the rectangle that I drew. Look at here. Here I've divided it into two. So it means that a triangle equals half of what? Rectangle. I hope you can see it. I hope you can see it. So it means that a triangle is half of what? A rectangle. Now, when you come to the area 2, what is the area of a rectangle? Let's substitute it here. So area of rectangle is what? It's length times breadth. So I'm going to substitute it in place of what? R. I'm going to get LB or LW here. LW or LB. Yeah, so when you come here, look at here. You see, this one is the length, right? And we have some, this actually right angle triangle. And so when you come here, this side is what? Is the rate, right? We can use it to represent here, but in this case, we've seen it that this is the height of the what? Of the triangle. This is the height of the triangle. So instead of us writing rate rather, we are going to represent the W width or breadth with height. We are going to represent width or breadth with what? Height. So we'll be getting half. Now the L2, the length, since there is only one side which is equal to the length, that is the base. That is the base. So you are not no more going to use the length again. You are going to use what? The base. Beautiful. So we're going to get the base here. We'll be having 1 out of 2 times the base times the height. I've used these variables to represent it. So now, this is the area of what? Of a triangle. This is the area of a triangle. Is that understandable? Let me know in the comment section. Say yes, it is understandable. Now, I've done a video of how to comment under YouTube channel in the description, or and then how to, maybe I'll do the one to subscribe and other ones as well. So you have to comment under it whether you understand or not. Say yes, I understand, and then if he doesn't understand, say no, I don't understand. So now area of a triangle equals half base times height. Half base times height. This is area of a triangle. If you don't understand anything as well, that is why we are students. That is why we are students. We are still learning. So if you don't understand anything, I will advise you to ask. Okay, anything that you don't understand, I'm going to advise you to ask. So this is the formula for the area of the triangle. Let's check the perimeter. Since the perimeter is the sum of the sides around a figure, this side is one side, this side is the height, and this side is the base. So we are going to have our perimeter of a triangle as the sides, one side plus the height. Actually, it's just sum of the sides. It's just the sum of the sides. So now the side is representing the height and the base. So we're going to S plus H now plus P. But you can get a triangle which is like this. You can get a triangle which is like this. You see, they are all triangles, right? They're all triangles, and then they are all cut from rectangle. They cut all of them from rectangle, despite it's different type of triangle. So this one too, it means half of it is what the triangle is the same thing. But here, you are going to calculate the height. You are going to use the apex point here where they meet to the base. So perpendicular line from here to the base. When I say perpendicular, it means a line that meets another line at 90 degrees. At 90 degrees. So here will be 90 degrees. Now, say when they ask you the perimeter from here, you are not going to use the height. You are not going to use the height because perimeter is what? The distance or some of the distance, some of the length around a figure. So if here is A, B, and C, the sum of the length, which is A, B, C, is going to be the perimeter. You'll be having A plus B plus C. Well, thank you very much. Okay, let's continue. Let's continue. Oh. Let's move on to parallelogram, 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 parallelogram. Parallelogram is a figure. That's how I always remember it. Parallelogram is a figure, it's a rectangular figure that has been tilted a bit. It seems someone has pushed it like this. Woo. Have you seen? So it's not normal, it's no more straight. You've tilted it a bit like this. You've tilted it a bit like this. So that's how it is, like you pushed a rectangle. You push a rectangle. That is a parallelogram. So always when you hear parallelogram, it's a what? It's like a pushed rectangle. So let's draw a rectangle here. Let's draw this rectangle here. Now when you push this rectangle, push it like this, you are going to have something like this, because you pushed it. Is that understandable? Because you pushed it. You push it, so it's going to tilt. It's going to tilt like you are falling down like a tree and you stop one side. What Michael Jackson used to do. Yeah, he used to do, and then he moved this side. I can't do it. I can't do it. Yeah. So this is a rectangle. This is a rectangle, and then we have gotten parallelogram from it. So let me make this one broken line here. Make this one broken line. This main line. This one will become main line. This also broken line. For you to know how it looks like, this is the main line. Yeah, can you see it on the board? So this is a parallelogram. So always when you see a tilted rectangle, it's called parallelogram. Parallelogram. And this side is parallel to this side. This side is also parallel to this side. This side is the same as this side. This side is the same as this side. Because it's what is a rectangular figure which has been pushed a bit. So its dimension doesn't change. It just what pushed a bit. Pushed a bit. Yeah. Just pushed a bit. Okay. I hope it's clear. The understanding is clear. So let's continue. When you say parallel lines, this sign I've written here, a line that does not meet goes usually the same direction and doesn't meet. The interval or the distance between those two lines are equal. So these two lines, the distance between here and here, they are equal. So that those are what parallel lines. Note that parallel lines. And then you have perpendicular line. As I told you, they meet at what? 90 degrees. Beautiful. They meet at 90 degrees. This is the sign to represent 90 degrees. So this is perpendicular line. These lines are parallel lines. These lines are parallel lines. Okay, so let's dive into how you are going to come up with the area of a parallelogram. Area of a parallelogram. Now, you've seen that parallelogram is a rectangular figure which has been tilted. Yeah, which has been pushed a bit. Yeah, it has been pushed a bit. So it's not a big deal for you to come up with parallelograms area if you know the area of a rectangle. If you know the area of a rectangle. So let's check here. A rectangle area is what? Length times what? W, or width or breadth. Yeah, length times breadth or width. Any of them is correct. So when you come here, this thing has been tilted. We've pushed it. We've pushed it here. So it has been tilted like this. This is a broken line. So it has been tilted. Now this is how you can come up with the formula. What is the area of a, this is what, length times breadth. When you check this shape, you will see that this one has been slanted now. It has been slanted, but it's not perpendicular as this. Or yeah, it's not perpendicular as this, or as straight as this, as vertical as this. This one has been slanted. So always, since we know the area of a rectangle to be length times breadth, the parallelogram is going to be this side times this side. Is going to be what? The length. I can say the length here, which is here. Have we seen? Times what? Times times this side, not this side. The reason is that in rectangle, it wasn't slanted. It was not slanted. So we are going to make a height here, this height. So we use height to represent the h. Height to represent the h. And then this length is going to be base. We are going to use base to represent the what? So we are going to have area of parallelogram. Area of parallelogram as, so area is equal to base times this base times height. Base times height. Note that this is the same as the height. This is the same as the height. This is the same as the height. They have the same height since these sides are parallel. Since these sides are parallel. So it will be base times the height. Base times the height. So this is the area of what? Of parallelogram. And then when you're asked to find the perimeter, what is going to be if this side is A, this side is A, or this side is B, C, D? It's going to be what? Let me know in the comment section. Area, perimeter of a parallelogram. We have the sides around it. So let me know in the comment section. Okay. Thank you very much. I know you get it correct. Let me know right now. Okay. So let's move on. Let's move on to the other shape. Rhombus. Rhombus. Oh, I think. Let me write that side. Yeah. Rhombus is also a four-sided figure. Rhombus is also a four-sided figure. Now, we saw that, or we realized that the parallelogram is a tilted, or let me say pushed rectangle. which has been pushed. It has been pushed. But when you come here, this is a rhombus. Rhombus is not difficult to remember. Rhombus is a square which has been pushed. So this one is not no more a rectangle. It's now what? A square which has been pushed or what? Tilted uniformly. The reason why I'm adding uniformly is that the side, when you push the side, this side doesn't become curved. It maintains a straight line despite that. So the way this side slides is the same thing happens here. So this is rhombus. Let me draw a square first. Yeah, so this is a square, this is a square, this is a square. When you push it a bit, it's going to be like this. Let me make this side broken line. So it means that these sides are also going to tilt. These sides, mm. Yeah, so this is a rhombus. This is a rhombus. It has been tilted. It has been tilted, and we have it's a square which has been tilted. Oh, I'm not getting a straight line here. Oh, let's take it as this. I'm not having a straight line here. So this is a square which has been tilted actually. So with this one too, you can come up with it even if I've not taught you. I think so because when you get understanding with the parallelogram, you are going to also come up with this one. You are going to also come up with this one. Okay, I didn't write the name here, so this is parallelogram. You can remember the word when you hear parallel. So parallelogram. Yeah, so this is the spelling of parallelogram, and this is rhombus, a square which has been tilted. A square which, so here too, we are going to get the area. Since it's a square, we know area of a square as length times length. The reason why it's length times length is that it has the same side. So a square has the same side, which is length, length, and here, length here, length here. They are the same. So the area is going to be L square, which means length times length. Replacing the width in rectangle by what? L here. Replacing the width by L here. So this is going to be area is going to be what? It's going to be half. Sorry. It's going to be the height also. So we get the height from here. We will derive it based on a squares formula. So it will be half, so not half, the base times the what? The height. Since this one is the base times this one, this is square here times here. This is going to be also height here, and this is going to be base. So it will be base times height. Okay. Okay, let's continue. Before we continue, I've seen you guys that most of you are not still subscribing to the channel. Although I've taught you how to subscribe it, but most of you are still not subscribing and are still not sharing, are still not commenting below. I don't know what to say again, guys. I don't know what to say again because I'm sacrificing something here for you, but you can't appreciate it. If you are really benefiting or watching this one, just turn on the subscription box. It's not going to affect you anyway. It's going to help you to get notified whenever I post a video first. It's going to help you to do what? Get notified. When I say notified, it means that you are going to get alarm or something. It will be powering or any sound that will help you know that no, they posted a video on this topic. Oh, the topic that I suggested the last time, they posted a video on it. And then it will help us to also grow and bring you some of these subjects. We are here not to just teach and then give you the concept. We are here to guide you and prepare you well to the WASI and the BEC. So I'm waiting. Hit the subscription button now. I'm waiting. Now comment. I've asked you so many questions here. Even if you understand, let me know. Comment. I'm listening. Comment. I'm waiting for you here. Now share it to friends. Share the link. Share the link. Share the link so others will also benefit. Share the link to friends. Like it. The like, just there is a hand there like this. Hand there like tap on it. Like it. You're not done. I'm waiting. Beautiful. Thank you very much. Let's give applause to you. Let me give you applause. Yeah, you've done really well. You've done really well. Always when I post a video, these are what you have to do to also what show appreciation and also help us grow this business. Oh, sorry, these lessons. Help us grow these lessons. Okay, so let's continue. Here we've got to know that the area of the square is what? Base times height. Base times height. Okay, so let's move on to what again? Let's move on to trapezium. Trapezium. So this is how trapezium looks like. Trapezium. I think okay. Okay, so this is how trapezium looks like. Now trapezium is it's a figure that has two sides para. Trapezium. These are the properties of trapezium. So trapezium, it has two sides para. This side and this side, they are para. And then it has a height too. So trapezium is a four-sided figure which has two sides para. That is this side and this side. And then the two other sides not para. The two other sides are not is not para. So these are the properties. Whenever you see a four-sided figure having two sides para and height, it's called a trapezium. So with this one, it also comes from rectangle. It comes from rectangle. Can you see it? Trapezium also comes from rectangle. So when you're writing the area of the rectangle, since this side and this side is not equal, trapezium the sides are not equal, but it has two sides with para. It doesn't mean they are equal. Yeah. So it means the distance between here and here they are the same and they are moving the same direction. So when you come here, this side and this side, let me use A to represent here and B to represent here. AB. Yeah. So when you come here, since this and this side is not the same, the way we are going to get the base, this is a rectangle, or the length, is that we are going to add this one plus this one. The reason we are going to add this is that they are not the same, so we'll add it first and then divide it into 2. We divide it into 2 so that we get the actual base. Do you understand it? Let me know in the comment section. Yes, I understand the trapezium the way you taught me. Yeah, so when you come here, you see, with this one, if you are to find the area, it will be length times this one. But here, for us to get the length, they are not the same. So we can't use one for this. So we have to add up the sides together. We have to do add up the sides together. So we are going to get half of the sides, the parallel sides, which is what? A plus B. Times the height. The reason why times the height is that in rectangle, we know this one as perpendicular and this is slanted. So we can't use this one unless we use what? This one, which is the height. So we'll be having times height. Or you can use H to represent it. So this is area of trapezium. This area for trapezium. If here it's C and D, let's find the perimeter. The perimeter is going to be the sum of the sides. Beautiful. So it's going to be A plus B plus C plus D. A plus B plus C plus D. That's how it's going to be. Okay, now this trapezium, I told you that this one, is a four-sided figure with unequal sides, which has 2 of its lines parallel or sides parallel. So when you get a shape like this, this side doesn't look exactly as this side. This shape, it doesn't look exactly as this shape. So I want to ask you, is it parallelogram? Let me know in the comment section that this is object A. This is object A. Object A. So let me know that this object A, is it parallelogram or not? This one too. Yeah. Let me know if this one too is parallelogram. This shape too is a parallelogram. Let me know. And then let me say here is A, here is B, C, D. Here is A. This is object B. So assignment 1, another one is here. They are too close. So let's use A to represent here, B here, C here, and D here. This is object B. So now what you are going to do is that you give me, okay, trapezium 1, object A. Maybe it's not a parallelogram. If you say it is a parallelogram, state the area of it. state this area of object A, and then use the dimensions. When I say the dimensions, this is the size, the letters assigned to it. Use it to calculate, right? Use it to give me the formula for what? The beautiful formula for the trapezium. The same goes to here. Let me know if the question is clear. So this is assignment 1. You give me it in the comment section. Give it to me in the comment section. Now I've also started the YouTube community whereby I've posted a video. I posted the questions, and then we can also chat there or communicate there. So I'm going to also help you in there as well as in the WhatsApp group. If you are not familiar with it, let me know in the comment section. I'm not familiar with the YouTube community. How can I access there? Then I will teach you how to do what access there. So these are the 2 questions that I've given you. Let's move on to the next session. After that, you solve some 3 or 4 questions on that, and the next time you meet again, you will dive into it and solve more questions with this one, more practical and thinking questions with this one. So let's move on to the last shape. We are going to talk about kite. Kite. How kite came about. How kite came about. Kite. We've talked about rhombus already. Oh, the rhombus. Did I write the area? No. We talk about trapezium here, rhombus. Yeah, rhombus. I wrote the area. So that is the rhombus. But there is another area for rhombus. How to calculate the area of a rhombus? I told you the rhombus is like this. It's a square. Can do it this way. So this is a rhombus. It's a square which has been pushed. It's a square which has been pushed. So this is a rhombus. Now you can. This is one formula for area of a rhombus. I told you the area is what? The base times the what? The height. Fantastic. The base times the height. Yeah, please, when I'm teaching and you want to make notes, you can pause the video and then make the note that you want to make, or write the question that you want to make. If you didn't get the concept well, you can go back, pause, and then listen to it carefully. Okay, so let's move on again. I told you it is the base times the what? The height. Base times the height. So this is how you can get the area of rhombus. One is also product of the diagonals. When they say diagonals, the lines that intersect it, this line from here to here, and from here to here, from here to here, and from what? Here to here. Those are called diagonals. So one area is also, oh, one area is also, I'm coming, sorry. We have one area here equals product of diagonals. We have one area here as the product of the diagonals. Yeah. So the diagonals is the line from here to here times here to here. This is how they come up with the formula. You see, this shape is like this. The same thing as this. This also round balls. Can you see? Despite I've raised it, now the apex is here. So when I draw it this way, I can get, can you see it? Yeah, so when you I wish I would do it with a card for you to see what I'm talking about. But when you erase this one up, when you raise this one up and you put it back to where it is, I don't know, I wish, I think I have to use card for it so that you get the insight understanding well. Yeah, so I will draw cards. I will draw in the next session. I will do one short video of how to come up with what area using product of diagonals. When you raise it, you see the distance between here, or the distance between this side to this side. When you raise it, you place it back to where it is. This side is going to come here. This is not drawn to scale. This side is going to come here. This side is going to come here. It means that side A, which is here, to side B here, is going to be where? Here. It's going to be here. Can you see it? Here to here is going to be here. And then when they raise it to this one will come here. It means this side, here to here, maybe A to C, is going to be from here to here. That's going to be A to C. So the A itself will come here. I think I have to draw it bigger so that you can see it clearly enough. Yeah, so as I was saying that these are the diagonals, line from here to here. It's a diagonal. Line from here to here. It's a diagonal. Can you see it? So I'm naming all the vectors where they meet. Here is A. Here is B, C, D. Here is O. Here is O. So if I'm to raise this one to come in, I'm raising this one to come here. Raising this one to come here. I'm raising it. So I'm going to have from here, this one will come here. This one is going to map to come here. So it means here will be O. When here is O, it means this CO here, CO here is going to be the same as the CO here. So when you raise this one and place it, raise it like this and place it here, you are going to have from here to here as the same as here, as the same as here. So if here is maybe, here is X, here is X, here is also going to be X. Can you see it? Yeah, here is also going to be X. And then when you raise it here, you see, you raise it like this. This side comes this way. This side is where? This side. So from OB here to is going to be the same as what? The OB here. So this is, if this is Y, If this is y, this is going to be y. Can you see it? The same thing, this one will come this way. So here will be O. This one, you move this side and raise it up to here. I will do one video of it, of how to come up with a formula. So this side is also going to be, this one will be here. Yeah, so this time when you raise, this one will just come here, and this side will be here. This other side will be this side. So here is also going to be y. This side is going to come here, y, and here is going to be what? X. So have you seen it? So it means that this side to this OA here, OA here is going to be, when you raise it, is going to be here. The O will come here. The O will come here. So it means that when this one comes here, this length from here to here is going to be the same as here to here. Can you see it? And then from here to here is going to be the same as here. I'll do the video of it, don't worry at all. So here is going to be also x, as x here. Here also is going to be y and y. Here is also going to be x. Yeah, you can check it out. I will do one video of it with a card so that it will be understandable. Okay, so look at here. With this side, so we've seen that it means this one, this side, let me use y to represent this side and x here, because here and here are the same. They are the same. So you can see that the length of this diagonal is the length of this side. And then, have you seen? That is y plus y. Y plus what? Y. So the length is the same as here. And then here too is the same as what? Here. That's where the rhombus comes in. Is that understandable? Let me know in the comment section. That rhombus explanatory to the perpendicular or diagonals to the diagonals is understandable. Okay, so here, okay, let me know in the comment section if you want me to do the cut out cardboard to do the presentation for this one, or how to come up with the formula. If you want me to explain it with the cardboard, let me know in the comment section. If you don't comment it that I shouldn't, if you don't comment it, I'm not going to make it, because I will think you understand this one. Okay, so look at here. With here, this will be also x. So you use area for, we know that the area for rectangle, because this is a rectangular shape, is what? Length times breadth. Length times breadth. And then the length is the same as this diagonal, and then the breadth is the same as this diagonal. So it means that we can say area of parallelogram as what? Area of a parallelogram as what? Beautiful. As the product of the diagonals, as I've written here, product of diagonals, product of the diagonals. Let's move on to kite. After that, you go to break and come back. Okay, so with the kite, this is how kite looks like. Kite looks like a rhombus, but you should be careful that kite has two sides equal only. Okay, so kite is drawn this way. The difference between kite and rhombus is that the kite has two of its sides equal, and then other two equal. So you can use this sign to represent it. Here is equal to this side, and then this side is equal to this side. That's the difference between kite and rhombus. But as for rhombus, it has all the sides equal, because it is a square which has been tilted. We've pushed it a bit, as I told you, I pushed it this side, so it has been tilted. So this is a kite. Let's see how kite area was brought up, or how you calculated for kite. So the kite also comes from rectangle. Rectangle. So with this one, it's the same way the rainbows, we derive the area which is the product of the diagonals for the rainbows. So I've promised you to use okay, I told you that if you want me to, if you don't understand the one on the board, I can take a cardboard, cut it out, and then come and explain it with you with the cardboard. If you are interested in that, let me know in the comment section so that I will do that for you. So with this one, if here is O, here is A, here is B, C, D. Look at how it came about. When you remove this side, let's take it as if you can take off this one, and this is fixed. So when you remove this one, it's going to come here. When you raise this one, it will come here. So it means that if this one comes, it means that this length is going to be here. Here is going to be what? O, and here is going to be OC. So this OC distance is the same as this OC distance. This OC here is the same as what? This OC, because when you raise it, it will be here. And then this OB the same as this OB. So if this is X, if this is X, it means this side is going to be here, and then here is also going to be X. And if this is Y, if from here to here it's Y, then it means that from here to here is also going to be what? Y. Is that understandable? Let me know in the comment section. Okay, so with this side, since this is X here, let's look at for this side. This one, to you raise this side and it will come here. So here is also going to be O. So it means this OC here is the same as this OC here. The diagram is not drawn to scale, so that is why you can see that this side is a bit shorter than this one. It's not drawn to scale. So this one, when you raise this side to come here, the distance between OC here is the same as the OC here. So it means here is also going to be X. Let's check out for this side. When you raise this side will come here, so the O will come here. If the O comes here, it means that the here from OA is the same as this OA here. So if this is X, or let me say if this is Z, if from here to here is Z, then it means that this side come here, it means this side is also going to be what? Z. This is understandable? Let me know in the comment section. Okay, so if this is Z, then let's check out for this side. When you raise it and come here, you get here to be as this. And note that this side is equal to what? This side. So here is also Y. And you are going to get the distance from here to here as what? Y. Okay, here we got it as, when you raise this side will also come here. So here is also going to be what? Y. Is that understandable? Let me know in the comment section if you understand it. This side, you're going to raise it up to come here. Yeah, so here is also going to be Y. And then let's check out for this side. When you raise this side to come here, from here to here, you are going to get this side will be here, right? This side is going to be here. So you are going to get here too as Y. And then, as a matter of fact, this side is going to be what? Y. Z. Sorry, here is also going to be Z. So based on this one, we know that if you are to calculate the area of a rectangle, it's what? Length times breadth. Length times breadth. So which is this side times what? This side. This side times what? This side. And this side is made up of Z. Z, and we have here too as what? X. So since we know that is this side, you can look at it. This is Z, and then z, this is also z. Here is z, and this is also z. So multiplying the length is the same as using this line. They're all the same. And then multiplying the breadth the same as using this line. And then multiplying the z here is the same as what? Using this side. It means that when you sum up this one, you are going to get the entire breadth for it. And when you sum up this one from here to here, the total distance, you are going to get the length for it. Let me know in the comment section if you understand or not. I'll be using cards. I'll cut off cardboard for you to understand it well. So since here is representing now the length, and then this side is representing the breadth, it means you are going to get, this is a diagonal. This is a diagonal. From here to here is a diagonal. It just means you are going to get the product of what? The diagonals. As the area. You are going to get the product of the diagonals as the area. The reason why it's a product of the diagonals is that this is now representing our what? This is now representing our length, and this is now representing what? Our breadth. So we know the area of a rectangle is what? Length times breadth. Fantastic. So we'll be having this side times this side. That is why area of a kite is product of diagonals. With the perimeter, I know you can do it because I've already explained perimeter to you. Perimeter is the distance, sum of the distance around the figure. So from here to here, plus from here to here, plus from here to here, plus from here to here. But we know that kite has two sides equal. So if from here to here is A, it means that from here to here to is what? A. And if from here to here is B, then from here to here is what? B. So summing up as the perimeter, we are going to have A plus A here, plus B, another B here. So plus B plus B. So in total, we are going to get 2A plus 2B. Let me know in the comment section if you understand everything about mensuration 1. This is mensuration 1. I've intentionally not solved any question about this one. I've explained the question, the concept with you. But let's go out for break. We will come back in the evening, and then we'll come and continue with mensuration 1. We are coming to solve more questions and then more critical thinking questions for you to grasp this well. You shouldn't, if you have free time, you can also open your textbooks and then solve more questions from it. If there is a question that you don't understand, just post it in the WhatsApp group. Thank you for waiting to end. Subscribe to the button, share it to friends, and then comment below. Thank you. Bye bye.